So we will discuss about finite state machine and regular expression and their application to the lexical analysis. So it is in different part. This is part 1. First we need to discuss about strings and languages. So an alphabet is an infinite set of symbols. The example of symbols are letters, digits, punctuation, etc. The set 0, 1 is a binary alphabet because here only 0 and 1 is present. ASCII is an important example of an alphabet. It is used in many software systems. A string can be defined as follows. The string over an alphabet is a finite sequence of symbols drawn on that alphabet. In language theory, the terms sentence and words are used as a synonym for the string. The length of a string The length of a string S is usually written as S by vertical line in the number of occurrence of the symbols in S. For example, banana is a string of length 6. Empty string is denoted by epsilon. The language is a countable set of strings over some fixed alphabets. This definition is very broad. Abstract language like phi, the empty set, or epsilon in curly brace, the set containing only empty strings, are languages under this definition. Operations on language. The lexical analysis, the most important operations on the language are union, concatenation, closure, which is defined as formally as follows. The union of L and M, you can see L union M is set S where S is in L or S is in M. Similarly, concatenation L dot M. So ST is a string where S is in L and then T is in M. Clean closure similarly defined from 0 to infinite. It is the repetition. Positive closure is the part where epsilon is not present. We take one example. Let L is a set of letters, D is the set of digit, and we may think L and D in two ways. Option 1. Here L and D are respectively alphabet in uppercase and lowercase and of digits. Option 2. L and D are languages, all of those all of whose strings happen to be of one length 1. We can construct some other languages by applying some operators on language L and D. L union D, we can say this is the set of letters and digits. L dot D, the set of 520 strings of the length 2. L to the power 4, it means that set of all 4 letter strings. L asterisk is the set of all strings and letters, string of letters including epsilon. L dot L union D, it indicates the set of all strings, letters and digits beginning with a letter. D plus, it represents set of all strings of one or more digits. Regular expression and their application to the lexical analysis. Suppose we want to describe a set of valid C identifier. It is almost like this. L in parenthesis L union D asterisk. The difference is that underscore is not included here. We are able to describe identifier by giving the name of set of letters and digits by using the language operator union, concatenation and closure. This process is so useful that a notation called regular expression has come into common use of describing all the language that can be built from these operators applied to the symbols of some alphabets. In the notation, if letter underscore is established to stand that letter or underscore and digit is established to understand one for any digit. There we could describe C identifier by following. Letter underscore initially we have added, it means that it can be letter or underscore, and in parenthesis there can be the combination, that is the letter underscore or digit. Letter underscore in parenthesis letter underscore or digit asterisk. The vertical bar means union. The parentheses are used for groups of expression. The star means zero or more occurrence of, and the just a position of letter underscore. The regular expression are built recursively out of a smaller regular expression. using the rule described as follows. Each regular expression R denotes L of R, which is also defined recursively from the language. There are two rules from this basis. Number one, epsilon is regular expression. L of epsilon is in curly brace epsilon, that is the language whose whole whose sole number is the empty string. If A is symbol in sigma, then A is regular expression. L of A is equal to A in curly brace. Induction. There are four parts of the induction whereby larger regular expression are built from a smaller one. R and S are regular expression denoting L of R, L of S respectively. So in parenthesis R vertical line, S in parenthesis denotes L R union L S language. In parenthesis R dot R in parenthesis R dot in parenthesis S is a regular expression denoting L of R dot L of S. R asterisk is the regular expression denoting L of R, that is the language R which is can be multiplicative any times. Simply R is a regular expression denoting L of R. As defined in regular expression after it often contain unnecessary pairs of parentheses. We may drop the certain pair of parentheses if we adopt the convention that the unary operator asterisk has highest precedence and is left associative. Concatenation has second highest precedence and left associative, and vertical line union has lowest precedence and is left associative, which means that this in parenthesis A vertical line parenthesis B asterisk parenthesis C can be written as A vertical line B asterisk C. Both are the same. So the both the expression denote the set of strings that are earlier either single A or zero or more B's followed by one C. For an example, we take let sigma equal to A comma B, and regular expression A vertical line B represents A B. A vertical line B, A vertical line B denotes A B B A B C because A followed by A. E asterisk denotes any combination of A with epsilon. Similarly, A vertical line B denotes any combination of A and B. Similarly, here it represents A, B. These are the valid characters, strings of this language A comma B comma A B A B A. So multiple names of A ended with B. A language can be defined by a regular expression is called regular set. Regular expression R and S denote the same regular set as they are equivalent to R equal to S. For instance, this represents this one, that is A vertical line B is equal to B vertical line B, because A and B both A or B represent the same member in B vertical line A. If there are a number of algebraic laws related to regular expression, and the first algebraic law is commutative law, associative law, concatenation is associative law. All these things you have learned in the automata in the previous semester. So these are the basic things that you must know. I am just revising this part, assuming that all these things you know. I'm just skipping this part. Now consider the regular definition. For notational convenience, regular definition is used. So if sigma is an alphabet of the basic model, the regular definition is the sequential definition in the following form: D arrow R1, D2 arrow R2, dot Dn arrow Rn. So each Di is a new symbol, not in sigma, and not the same as any other is. Each Ri, that is the regular expression over alphabet sigma union D1 comma D2 dot Di minus 1. By restricting Ri to sigma and previously defined as these, we avoid the recursive definition, and we can construct a regular expression over sigma alone for each Ri. We do so by first replacing using use of D1 in R2, which cannot use any of the D's except D1, replacing use of D1 D2 in D3 by R1 and R2 and so on. Finally, Rn we can replace. We take one example. So let us consider letter underscore can be represented like this: capital A, capital B, dot dot dot, small capital B, capital Z underscore. So digit can be, so ID finally it can be represented by letter underscore or ID digit asterisk. So generally italic symbols are used here. Regular definition example 2. So we can define a regular definition for an unsigned number. You can see here digit can be defined by 0, 1 or 9 dot 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 9. Digits can be digit dot digit asterisk. Optional fraction can be represented by dot digits or epsilon. It means that fraction may or may not be present there. Optional exponent can be represented by e, and in plus and minus epsilon digit or epsilon digits, optional fraction and optional fraction. So number can be defined by first it will be digits and then optional fraction and then optional exponent. The regular definition is a precise definition of this set of strings, that is optional fraction is either a decimal point followed by one or more digit or it is missing. Similarly for the plus symbol, and note that at least one digit must follow the dot, so number does match one dot and it does not match 1.0. Extension of regular expression. Extension can be added to regular expression to enhance the ability to specify the string patterns. It was first incorporated in Unix utilities such as Lex. One or more instance can be represented by R plus. Uh, plus has same precedence. The plus has same precedence and the associativity has the operator asterisk. So two useful algebraic laws we have here. R asterisk can be R asterisk or epsilon, its clean closure, and R plus can be R asterisk or R asterisk R. So this is the positive closure. 0 or 1 instance. Unary postfix operator question mark means 0 or 1 occurrence. If we write R question mark, it means that it is equivalent to R or epsilon. Question mark has the same precedent as the associativity as asterisk and plus. Character class. A regular expression a1 a2 dot dot an can be represented by shorthand a1 a2 dot dot an, and it should be the logical sequence. ABC in shorthand, we can write a or b or c. A to Z represents a or b or dot 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 az. For an example, using shorthand, we can rewrite the regular definition as follows. Letter underscore can be written like this. Digit and can be written by 0 to 9. And ID can be represented by letter underscore initially and then in parenthesis letter underscore or digit asterisk. So this is the representation of variable in C and Java. And it can be represented in small form like this. Letter underscore arrow a dash z, a dash z, capital and small, and digit can be 0 dash 9, and I can read ID can be letter underscore or digit asterisk. So these are the same thing. Using the shorthand, rewrite the following regular definition. So solution is like this. I can write digit can be defined by 0 dash n, digits can be defined by digit plus, and number can be defined like this. Digits in bracket have question mark dot digits because it can be 0 or 1, and e plus can be the question mark and then the digit can be the question mark. So here is the regular definition can be written like this also. Thank you so much.